Oh yeah, so you just need to know about these studies. We talked about the Stroop experiment. That was the one where people just read the words, or read the color words, or then they read the color words that were printed in the wrong color. So the word red, but it's printed in green. And then you look at how long it takes people to complete that task. So we use that as an example of a repeated measure design, because you have the same people reading the words either just in black and white or printed in the wrong color. And then the Mozart effect. Does anybody remember that one?
The idea of playing Mozart, playing music by Mozart had an effect on learning, especially popular with infants and small children.
Yeah, and they found out through a relatively well-designed study that this wasn't a real effect. They used different types of music, and just, I think they might have had one with white noise, like thunderstorm noise in the background. And they found out that what they thought was the Mozart effect was actually just a practice effect. So, yeah, so you'll need to know about that example. And if you want to, I can go over that one. Does anybody want me to put that one up so we can talk about that one? Okay, most of these are detailed in your textbook too.
Wait, so do we just need to know about the Mozart, like there was just no real effect on listening to?
Let's see. Let me look here. I know I've got that one in here. Yeah. You'll need to know about the design of the study. If they used counterbalancing, what type of counterbalancing was used, and what was the conclusion. Yeah. Let's see here. Okay, so this next one, I remember, caused people some headaches. The advantages and disadvantages of multi-level designs. I think there was one that people had a hard time figuring out, which might have been the disadvantages of multi-level designs. Does anybody remember what these were? Let's start off with the advantages. Why would you want to do a multi-level design as opposed to a simple single-factor design?
Well, you can account for compounds.
What's that?
You can account for compounds.
Not necessarily. I mean, confounds are usually accounted for by using good control procedures.
Well, I guess not compounds, but I'm not saying you can test like in the coffee experiment, you can test different amounts. So basically just be more specific.
Yeah, you get more detailed results using a multi-level study, and I think the example that we gave was that classic finding of that curvilinear relationship between arousal and performance. So if you just looked at performance when people were at really high levels of arousal and really low levels of arousal, it would look like arousal had no impact on performance, because at both really high and really low, people don't perform all that well. But at moderate levels of arousal, people get this performance boost. So by doing a multi-level study that looks at low, medium, and high instead of just low and high, you can actually find a trend like that. So that can be really useful for that purpose. And then what was the disadvantage? And this was more of a practical disadvantage. You need more participants if you're doing a between subjects design, and if you're doing within subjects, then the design is going to be more complicated and take more time. You have to work out some pretty detailed counterbalancing methods. So again, that's a practical disadvantage. It's not saying that there's a real drawback to this type of design. It's a better design, but it just takes a little bit more work and resources. And see. What type of statistical technique should be used to analyze the results of a multi-level design?
Just t-test.
What's that?
Don't you usually use
T-test.
Well,
no, you use the kind of, yeah, ANOVA or something?
yeah, you use an analysis of variance. Remember, I gave that example. I said you could use multiple t-tests, but then that's going to increase your probability that you'll commit a type 2 error, or sorry, type 1 error. So I put up that graph showing, well, you'd have to compare this level to that level to that level, and so on. And so you'd be doing about 10 different t-tests in order to do that analysis. But with an analysis of variance, it holds that alpha level at 0.05, so you don't run into that problem. So you need to make sure to do the analysis of variance because it reduces your chance of committing a type 1 error. It keeps it at 5% basically. All right, and then what was the purpose of post hoc testing?
If you find a significant ANOVA post hoc, figure out what it's.
Yeah, that's exactly right. So the analysis of variance is nice because it ensures that you only have a 5% chance of finding a false alarm, but it only tells you that there's some difference among these levels. Right? So you might have 5 levels of your independent variable. The analysis of variance will say, hey, there's a difference, but it won't tell you what it is. The post hoc tests will say, all right, well, the ANOVA said there's a difference, and the post hoc test reveals that it's a difference between groups 2 and 3, but then there were no differences between the other groups. So that's really important if you're doing an analysis of variance. Well, we're just about out of time. I don't think we'll start chapter 8 since we've got like a minute and a half left. But we'll finish up 8 and 9 and then talk about 10, 11, and 12 in our second review session on Monday of next week. So